Yeah, so let me introduce myself. I am Bhaskar Chinnapaka. I have 13 years of experience in data warehousing, data engineering, ETL and ELT. So I worked on both environments and on-premises and cloud environment. So I worked on two clouds, AWS and BigQuery, that is GCP BigQuery. So I am your trainer. So let me give you the uh, the services that we are going to cover. And before that, let's start the basic things like why we need to go for cloud. Okay, so let me share my screen. I have some PPTs. Just want to share with you. Just give me 1 minute. Is my screen visible? Yeah, is it visible now? Hello.
Hello. Yes, Bhaskar, it's visible. Hello.
Hey Prabhu, Naveen,
Ah,
Suprit.
Bhaskar, it's visible.
Oh,
Am I
super. Yeah,
audible?
yeah. Now you are.
Yeah, thank you. It's visible.
Yeah. Coming to this, our course like Redshift, Amazon Redshift. So before going to Redshift, so Redshift is basically, cloud data warehouse. We can't say database and data warehouse. There are some differences. So before going to AWS Redshift, let's say first why we need to go for cloud. So basically, so when there was no cloud, I mean, like maybe 10 or 20 years back. So in that case, if you consider any e-commerce application, any enterprise which maintains some e-commerce application, so the e-commerce application usually you take Amazon, Amazon app also, or like Flipkart or whatever. So during weekends or in the festival seasons, the orders will be more. I mean to say the load will be high on the server. So when the load is high on the server, that means the server has to process all the requests. I mean, across the globe, there are, so many people they can order. So when they apply, I mean, they connect to the server, I mean, they post their order, and the server should be able to, the process the requests. For that purpose, what that enterprise or company does is they establish the infrastructure. That means to process heavy load, they need to maintain, proper compute resources, proper storage. So storage and compute, these are very critical. So how the data is stored, how the data, I mean, how the requests that are coming from the different customers across the globe, how the requests are processed. To process all the requests to handle the heavy load on the server, they need to establish the infrastructure. So for that infrastructure they had to spend a lot of money. Right? So for that purpose they spend a lot of money and they establish the server to handle high loads. But what if the load is very low? They The enterprise already set up the infrastructure, all the compute and resources, all the storage resources, but the load is very less. So we can't guess, right? So when the load will be high, when the load will be very less. So once you set up the infrastructure, so being an organization or enterprise, so you should make use of them to, process the request from the different customers across the globe. But in this case, if the load is very less, then at the time, the all the money which was spent on the setting up the infrastructure would be wasted. So that is unnecessarily we are spending money if the the load is very less. So if it is high, yes, we can handle it, but the load will be on the server that will vary over the time. So sometimes it is very less, sometimes it is very high. So when the load is very less, then the infrastructure which we set up, I mean, which the enterprise set up would be wasted. The all the resources would be wasted, all the money would be wasted. So the infrastructure would be sitting idle. All compute resources and storage resources would sit idle if the load is very low. Then in that case, then the cloud comes into picture. So that means, so right, when you already set up, when the organization or enterprise already set up all the compute and storage resources, then the load is very less, then these kind of challenges will be there. Low utilization of infrastructure, whatever the infrastructure that you set up, that will be utilized very low. And we don't know when the load will be higher, low, and the cost which was spent on infrastructure would be wasted. So these kind of challenges will come across. So that is where the cloud became popular. So cloud comes into picture in this case, and cloud resolves all these challenges. So here, basically, cloud is nothing but whatever the services use, whatever the resources use, pay for that only. And how long you're using, pay for that only. You don't have to set up infrastructure, right? You just rent the resources. That means CPUs and storages, everything. You can rent it, you can use it as long as you want. Then once you're done with your work, just release the resources. So you spend money for that resources which you used, and how long you used, that would be, you need to pay for that only. Just it is something like pay as per use, right? So this leads to low cost, so we can save the lot of cost actually. So then in this case actually, so in the case of before cloud, so we have to be very very keen on so guessing at what time the load will be high, at what time the load will be less. So that kind of headache was there when the cloud was not there. But in the case of cloud, when you start using cloud, you don't have to guess. So when the load will be high. So whenever the load is high, just procure. So, I mean, you provision the resources, and you just fulfill all the requests which are coming from the class customers. Then you just release your resources. So in that way, the cost will be less, you know, and you don't have to guess when the load will be high or less, right? So just pay as per usage of the resources. So this is how the cloud is very useful nowadays. Now the cloud offerings in the market, we have so three major cloud offerings are there, like Amazon Web Services, Azure, and GCP. So Amazon Web Services is very popular nowadays. So in that too, in Amazon Web Services, we have the data warehouse that is Redshift. So it is very, very popular nowadays. So very good demand in the market. So when it comes to Redshift, so this is the architecture. But before going to the architecture, let's see what is massively parallel processing. So when I say massively parallel processing, why we have to see this one? Let's see that actually. See, you might have, if you come from the computer science background, so you might be aware about divide and conquer approach. That means when there is work and that is divided into different chunks, then each chunk is given to a different persons. Once that work is done, all the work would be merged together, and that would be the solution for the big problem. It is something like when you have a big problem, you divide it. You divide the big problem into smaller problems, and that smaller problems will be resolved. Then each and every smaller problem there will be solution, and all the solutions will be merged together, and that is the solution for the bigger problem. In the same way, the massively parallel processing is nothing but, if you see, the any distributive environment is distributed computing environment. So there is the compute resources which are distributed. So in that, the compute nodes or compute resources, the chunk of work is processed. That chunk of work of each and every compute resource or compute node is given back to the next level, that wherein all the works, all the results are merged together, then that is given as a result to the client applications. So I mean to say here, if you see this the diagram, the Redshift architecture, there are like two types of Redshift architectures. One is Redshift serverless, another one is provisioned. So when I say serverless, this is serverless data
Yeah,
warehouse.
Bhaskar, I'm
Yep.
sorry. Uh,
Mm.
I'm actually seeing only one note application. Are you showing any PPTs or
Yeah. Oh, you're not this is not visible.
uh,
I'm sorry. I
we can only
actually
see
shared
this
entire
one note?
screen. Oh, you should have mentioned the beginning only. I thought you are able to see my entire screen. Let me reshare.
Okay.
Can you see now?
Yes, yeah, we're seeing it now.
Oh, I'm
Thank
very sorry, buddy. Very
That's
sorry.
okay. That's
So I was going through these PPTs.
okay. That's
Why
fine.
cloud, as I explained earlier.
Yeah,
So
we
they
are, I
were the
think I mean I'm good with that. Yeah, that's fine.
okay,
Thank
okay.
you.
I'm sorry. Yeah, fine. So this is, if you see the Redshift architecture, there are like two types, as I mentioned earlier. Serverless data warehouse, that is serverless, Redshift serverless, and this is provisioned. So if you log into the console, AWS console, so if you try to type Redshift, you will see two things: Redshift serverless and Amazon Redshift. These two things you see. So basically, I just want to explain. So because in some of the interviews, I took interviews. The guys who came for interviews, I asked the question. So what do you mean by serverless? People said like very crazy answer. So it is something like, when there is no server. They said simply, there is no server. Serverless means there is no server. So I was laughing like anything. Okay. So this is basically serverless, nothing but you don't have to maintain the server. So that means, so being an enterprise, usually before cloud, as I mentioned earlier, we have to maintain complete infrastructure, complete server. Server, nothing but it will have compute resources and storage resources. That means you need to store the data and you need to process the data. For storage, you need to have the storage resources. For computing, you need to have proper CPUs. So all these infrastructure would be maintained by the enterprise only. Now, when it comes to Amazon Redshift serverless, this means you don't have to worry about the server infrastructure. So how the server and how many nodes are there? So what is the RAM size? What is the CPU? speed, you don't have to worry about it. So when you choose your Redshift serverless, it the infrastructure is completely maintained by Amazon only. So that means they'll give a proper server, that is Amazon Redshift server, the Redshift cluster, wherein you don't have to worry about what kind of node it is, what kind of Redshift cluster it is. So it is completely black box for you. So based on your requirement, when you fire a query within the Redshift, then based on the query data, I mean underlying tables. So like say for example, you have two tables in your queries you're joining. If the tables are huge, the computing the joining and getting the results from the query, that may take a lot of time. So based on your data, based on your query plan, the Redshift serverless, the Amazon will provide the compute and storage resources internally, and this is black box for you. How many, I mean, how many nodes are there? How much memory resource is being used for your query to fire a query? So you don't bother about it. So based on that only you have to pay. Okay, so that is serverless. So that means you don't have to worry about the server. But when it comes to provisioned cluster, so this one actually will be having, we need to properly configure the cluster, how many nodes you want, what kind of node. So you'll get to know. So different kind of nodes like DC2 node or RA3. So these kind of nodes are there. Basically in each and every DC2 node, what is the CPU power, I mean computing power, and what is the memory in each and every node. So that kind of information you'll get to know, so when we configure the AWS Redshift server. So for now, just I am trying to explain the architecture of the Redshift. So the Redshift cluster, within the cluster, provisioned cluster, you'll be having nodes. These nodes are called compute nodes: CN1, CN2, CN3, CN4, up to CNN. N number of nodes will be there. In addition to these nodes, we'll be having a leader node. So what is the use of leader node? So basically, the leader node, to this leader node, the client applications are connected. I mean to say for example, you have dbeaver or Todd application or SQL developer, some front-end applications. Okay, so integrated development environment. Right. So there actually you fire a query. So that means it is called client application. From the client application, you are running your query. That query is submitted to leader node. So you see here JDBC, ODBC. So Java database connectivity, and this is Open Database connectivity. So this one's using JDBC or ODBC. There is another connector, data API. So usually we Redshift data API. We use this Redshift data API in the Glue or Lambda. So basically, so if you are aware of the ETL architecture, the critical ETL architecture, so data would be extracted, transformed, loaded. So in our case, we are looking at AWS Redshift. In ETL architecture, where are we is we are in the last stage, that is loading. So when we load, that data load is happening on the Redshift, AWS Redshift. So here, this compute nodes will get the work from the leader node. That means the leader node, whenever leader node gets the query from client applications using JDBC or ODBC or data API, that query is analyzed in the leader node. That leader node will come up with a plan, that is execution plan. You must be aware of explain plan, because I think I'm guessing you guys are uh, working professionals. Maybe some are not. Maybe some people are learning just now only. So basically, whenever the query is fired, so internally for that query, the query execution plan will be generated. So within the AWS Redshift, be it Oracle, SQL Server, Redshift. So the query execution plan will be generated. So in the case of AWS Redshift, the query execution plan, query analysis, everything is done by the leader node. And leader node will have the proper information about which compute node has how much load and what is the processing power, compute power of each and every compute node. That metadata is available with the leader node. This leader node will come up with execution plan, and the query execution, some chunk of the work is given to compute node 1, next some chunk of node work is given to compute node 2, and so on like that. Once the compute node is done with the work, it will submit the result to the leader node. Next, compute node 2 also submits the result to the leader node. In the same way, compute node 3 and node 4. So they submit their results to the leader node. So the compute node 1, whatever the result it is giving, it is internal. That means it is not the whole result. It is, the result for a smaller chunk, smaller work or smaller problem. So all these chunks are merged here, conquered here. So when I say conquered, it is merged. So that means initially the query is given to leader node. The leader node is dividing the work into smaller chunks, and each and every chunk is given to different nodes, compute nodes. That compute node is working on that particular problem, and it is computing the result, and it is giving the result back to the leader node. So that's how the leader node is dividing the work, and the compute nodes are working on the smaller chunks of the work. And these compute nodes, once they are done with the work, they are submitting their result to the leader node, and the leader node is conquering all the smaller results, which is represented as the result for the whole query, which came from the client application. So this data API, so when we talk about Lambda or Glue, we can come to this data API. Even data API also kind of connector by which we can connect to the Redshift. Okay, so you must be aware of AWS Glue, that is ETL tool like Informatica Power Center, SSIS, Talent, or Matillion. AWS Glue also one ETL tool, one of the popular ETL tools nowadays in AWS. Whenever there is a requirement on AWS data engineering, there is, if you see the JD, there is definitely you will find AWS Glue and Lambda. So they are very, very, very important. So if you're planning to learn AWS data engineering, so definitely you have to learn. It is mandatory. You have to learn AWS Glue, AWS Lambda, along with the data warehouse, that is Redshift. Okay, so this is what divide and conquer approach. But what is the cluster basically, and what is this leader node? What is this compute node? So if you see the cluster, this cluster nothing but it is like a group of nodes putting together in order to perform the work, in order to uh, perform the query execution, query plan, and everything. We have the group of nodes. That group of node, nothing but it is a cluster, nothing but it is basically a core component. So under the hood, it is basically there would be n number of nodes will be there. Each node will have some compute power and storage. Okay, so the cluster is collection of one or more compute nodes. So in that cluster, leader node is very important. It will build the communication between outside client applications and Redshift cluster. And leader node coordinates each and every compute node. As I mentioned earlier, the work is divided and the work is conquered. Right? It is coordinated with the different compute nodes. A cluster can have, maybe 2 nodes, or 4 nodes, or 8 nodes, or sometimes 10 also, sometimes 20 also. So it depends on the requirement. Okay, so as I mentioned earlier, the client application interacts directly only with the leader node. So leader node is basically a kind of bridge which provides the communication or interaction between client applications and the Redshift. When it comes to the leader node basically, yeah, this is the leader node basically. And when it comes to compute nodes, the compute nodes, it will have its own CPU. Basically, compute node nothing but it's a computer, basically a computer, which will have the CPU basically, though the CPU will do the work and that result is given back to the leader node. And the node type could be, DC2 or REA3. So it depends on the type of node, the cost would be incurred, right? So this one, we have talked about the compute nodes. I said compute. I always, if you see the diagram over here, if you see the diagram over here, you see the compute node 1, compute node 2, compute node 3, and 4. But where is the storage? Right. So we should have storage and we should have compute. So both powers we should have, both resources we should have. But in this cluster, you don't see the storage. I forgot to mention over here. So here, this cluster is interacting with the different applications here. If you see, the managed storage is here, AWS S3, also Amazon S3, that is simple storage service. So RMS is that RMS nothing but Redshift managed storage. So that means whatever the data that is inserted, say for example, by using some insert statement, you inserted the data into the Redshift, or by using copy command, you inserted the data into the Redshift. So that Redshift data, where does it store? Where it is stored basically. So you don't have to worry about where is the storage. When you configure a cluster, automatically the managed storage is configured internally. The AWS will take care of the storage part here, the Redshift managed storage. So if you see here, Redshift managed storage is, it's a data where the, Redshift manage warehouse data. So whatever the warehouse data that we process every day, that data is sitting in the managed storage. It is nothing but Redshift managed storage. So when I say managed storage, you don't have to configure the storage, what amount of storage that I want. Whenever you configure a cluster, you configure the node, which type of node you want, you can choose it. There will be, some, radio buttons or check boxes when you click on that. So some DC2 type node or REA3 type node, you can configure it. You can configure the compute nodes, but you never see the storage. So how much storage I want? Is it 100 GB I want or 1 TB I want? So you don't have to worry about it. That is automatically configured by the AWS. So this is based on your data. Sometimes data would be high, sometimes data would be less. Based on your data, the storage will also scale up, scale down. So when I say scale up, if the data is very huge, then the Redshift managed storage will allocate more memory to store the data. Even in the case of compute node also, they're actually here actually, if the load is very high, in the case of serverless, I'm talking about serverless here. So in the case of serverless, if the data is very high, automatically AWS will scale up the resources internally. So for to give the result for this query, to process this query, the query which works on huge amount of data, then at the time the AWS will automatically scale up the compute on, and it will perform the result. It will compute the query and it will give the result back to the later. I mean, there is no node actually. It will directly give the result to the client applications when in the case of serverless. But in the case of provisioned cluster, when the query is working on huge tables, at the time you don't have option to scale up the nodes here because you already provisioned it. So if you want it again, you can increase the nodes, but for that nodes you need to pay. So that is the drawback. I don't say drawback, it is. So based on the initial analysis only, will the enterprise or organization will come up with the proper plan saying that, okay, we need these many compute nodes, this much storage. So that they'll come up with that kind of plan actually. So this RMS automatically uses high performance SSD. So SSD based local storage, it is a tier 1 cache. You must be aware of cache memory. So cache memory is very faster than RAM. Okay. So this kind of storage we have in the Redshift cluster. So in my project, I just want to show in my project what kind of cluster that we have. So our cluster is provisioned cluster only. You see here in our cluster we have 8 nodes are there. So these 8 nodes, just a second, let me, is it visible properly? Yeah. So this is a total 8 nodes we have. So in this 8 nodes, all the nodes are like DC2 type, DC2 large basically. If you see the next slide, it's, if you can see here, I intentionally masked this area, the endpoint, a JDBC URL, the cluster information I intentionally masked. So if you see the cluster identifier, this one, so whenever you configure a cluster, you'll see these kind of details, the general information. What is the cluster identifier? What is the status? Is it available or is it down? Okay, what kind of node it is? Based on the node type, we can say the cluster type. Now, our cluster is DC to large. If you see here, node type DC to large. I mean, so these compute nodes are there, right? This compute node is, my node is DC2 large. And the DC2 small is there, DC2 medium, DC2 large. So these kind of nodes will be there. So in my cluster, in our cluster, it is 8 nodes are there. So in the 8 nodes, each and every node is of DC2 large. So when it was created, so the storage used 94%. Okay. And the cluster ARN nothing but this is Amazon resource name. So that means in the Amazon Web Services in the AWS in the cloud, for each and every resource there is a unique name. So that is nothing but Amazon resource name for everything. If it is, if it is, Lambda. So if you create a Lambda function, for that Lambda function there is a unique name that is nothing but ARN, Amazon resource name for Lambda. If you create any some role, IAM role, or if you create any glue job, or if you create any DMS job, database migration service task, so even for every task or every resource whatever you create in the cloud, for that there is a unique name that is called ARN, Amazon resource name. And this resource name contain, see, ARN nothing but AWS Redshift. What is the reason region? AP nothing but Asia Pacific. In the Asia Pacific, we have different available zones, AZs, AZs, that is Southeast. So this is the reason Asia Pacific Southeast region. And what is the namespace? So these kind of information, if you can see. So I'll explain what is a region and what is available zone. So that will come to that part later. So this is sample cluster, not sample cluster in my project actually. So this is one we are using actually. So in our course, for now, do you have any questions? Please let me know. There is one more
Yeah,
thing that
Bhaskar.
I'm going to cover. Yeah, please.
Bhaskar, we have compute nodes, right?
Yeah.
The data will be distributed to compute nodes,
Mm-hmm.
right?
Mm-hmm.
If
No,
one
not
of
data.
the okay,
Not
if one
data.
of the uh,
It's
okay,
not
if
data. Within the compute node, we have again, we have slices. Yeah, yeah. Please
okay,
go with your question. I'll let you know. Yeah.
uh, if one of the compute nodes down means what will happen?
Correct. 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 Yeah. For that purpose only, we have different available zones. Nothing but I have shown you, right?
Uh,
Asia Pacific Southeast.
Yeah.
See, Asia Pacific Southeast. This is the region basically. Within this Asia Pacific Southeast region, it is basically, Australian. I was working for Australian client, so this is basically Asia Pacific Southeast region.
Mm.
So in that Asia Pacific, we have around six available zones, I think, if I'm not wrong. So that means in one of the available zones, in each and every available zone, we have different, you know, the nodes actually. It's not single
Okay.
node, at least two nodes. Always at least two nodes. Minimum two nodes are required because if one node is crashed, if one node is down for some reason, then there is another node to take care of the work of the crashed node. That means the first node is down, and the first node, whatever the data is available, same dirt data is also available in the another node also. Because if the node 1 is down, that task is taken care by node 2. This concept is called highly available, HA, highly available. If one node is down, other node will take care of the work of uh, the first node. So this is possible only in the case of distributive computing environment. That is what
Okay.
distributive operating system, distributive computing resources. Even the Redshift also, Redshift, be it Snowflake or BigQuery, it is basically clustering nothing but. So we have different nodes. If one node is down, that node's work is taken care by the other node. So this is managed by the leader node. Leader node
Okay.
have Leader node has complete information: which node is up, which node is down, which node has heavy work. So this kind of information is maintained by the leader node. Yeah, next question.
But in this slide, that multi-age is known, and means you are not enabled multi-age. Even though one node down means the work will be continuous, or otherwise it will be halted.
No, in that case, the for your questions, if the data is not available in other nodes, if the data is there in only one node that is crashed, now at the time it is impossible to retrieve the data. But in the cluster environment, that is not the case. The highly availability is very crucial factor. So whenever we go for the cloud services, whenever you opt cloud services, definitely this is the first parameter, that is the crucial parameter. Highly availability is very, very important. If one
But
node is down, that
in
is
your application, your multi-age is off, na? It is showing it is no. No means you are not enabled multiple multi-age availability
yeah,
zone.
in this cluster it is like that, but multi is it is not multi available zone. It is single available zone only. That is Sydney region. It is, but in the Sydney region we have different nodes. I mean to
Uh,
say there are 8 nodes are there, right? So you're talking about multi-available zone. So this cluster is available only in one zone,
yeah.
not in the multiple zones. So if you change the region to different zone, so now we are working in Sydney region, Asia Pacific
Okay.
Southeast. So this is the region actually. If you switch it to some other region, you can't access this cluster. This cluster is available only in the Sydney region.
Okay,
If I
that is
if
the
I
doubt
if
I
I
have,
Yeah,
Bhaskar.
yeah, yeah, yeah.
You have 8 nodes are in single region. If
Single
one of
region,
the
yes.
node get down means the data in the node slices, how you are going to access.
Yeah, that is taken care by AWS Redshift cluster automatically. That's what you don't have to worry about how the internally the data is switched between the nodes. You don't have to worry about it. But
Okay.
whenever you insert your data, there are kind of distributive algorithms how the data is distributed. So it is like even distribution or all, or based on the key we need to distribute among these 8 nodes. So that is at the case in the case of whenever you insert your data, you can define whenever you define a table, you can give the distribution key or distribution style. That is a dist style. We can say dist style, right?
Okay.
So here, if you this is your question, multi-AZ is no. That means this cluster is not accessed by multiple regions. That means this is cluster is available only in the Sydney region.
Okay. Actually, I work on RDS. RDS we configure multi-availability zone because one
Yes.
of the node get down means the user will access from another node. Means the
Mm.
data will be available from we configure replications because one of the node down means he will access the same data from another node. Here you are doing
Okay.
data distribution means different data will be in different nodes. If one
Storage.
of the if one of the
Mm.
node gets down means what about the data? I got that doubt. I think you
Yeah,
understand what I'm asking.
yeah, I understood.
We
So
will replicate
internally
the
within the
same data in the different nodes in RDS. Here
definitely
that
here
here
here also definitely to ensure high availability, the data is maintained in different nodes. If one node is down and that data is taken care by another node, even the work of the crashed node is taken care by another node. That's how it is. In
okay.
RDS, which database that you work on? Is it Aurora
Postgres.
or Postgres? Okay.
Both
Yeah, yeah.
Aurora and
Aurora
Postgres.
flavor only, right? Yeah,
Uh,
yeah. Aurora has
in
the same
both
two things, right? Mm.
in both nodes we have similar data. There is no distributed data. Both nodes complete data will be available. That's why they won't get in case of any one of
Yes,
the node crash means they can access. But in this
correct.
cluster, you are saying the data will be distributed to all the compute nodes. That's why I'm getting doubt. One of the compute node get out without multiple availability zones means how they are good to access.
This is basically compute node. The storage is maintained here, Redshift managed storage.
Okay.
So if you see here, and this one you don't configure, as I mentioned earlier, this is
Okay.
basically it will take the data from this only, Redshift managed storage. This is basically the computing power lies with this.
Okay.
That's how. Okay.
Means even though one of the node gets down also, the user will
Yes,
access
work will
complete
not
data.
stop. Yes, work will
All
not
data.
stop. Yes,
Uh, do you face
that's what
any
I.
in your application? Do you face this type of issues, Bhaskar?
Not this
One of
issue.
the
So
node get
basically,
down.
there is one migration project basically. That migration project, it's not like one of the node is down and another one is taken care by another one is taking care of the work of that node. Not that case actually. What I faced is my cluster has 8 nodes, right? Same this
Mm,
cluster we used actually. So
mm,
in this,
mm,
what happens, so when there is one of the, migration projects, what happened, that the source data is there in the SQL Server. In the SQL
mm,
Server, there are like huge tables are there. In the SQL Server, that is on-prem databases, traditional databases, there actually we have complicate query. So wherein it's actually view. In that, there are like 32 correlated subqueries. That 32 correlated subqueries, and the SQL Server, it is nicely, indexes are nicely configured, indexes are nicely, defined. But indexing concept we don't have in the Redshift. But what happens, uh, the same view I have defined in my Redshift, and I was running the query. That
mm,
means 32 correlated subqueries are there in the select only, in the select statement only. For each and every column, to derive one column, there is one correlated subquery.
mm,
So because of that, 32 times I am running in a single view, 32 correlated subqueries are running. Apart from that, there are like 6 or 7 tables are there in the join. Because of that, I got the error saying that this cluster cannot handle. Please upgrade the cluster to 4XL or 8XL.
Mm-hmm.
This kind of issues I faced. I mean, our
Mm-hmm.
cluster was not sufficient to, run that query.
Okay.
So for that purpose, what I did is I split the query. I split that query into three different queries. So in the
Mm-hmm.
first query, I have 10 correlated subqueries, next 10 like that. After all these, I wrote the materialized view. I mean, first materialized view, I wrote these three materialized views. On top of these materialized views, I wrote a view. Then the
Mm-hmm.
problem was resolved. My manager said, no, we cannot upgrade the cluster, Bhaskar. So please do something so that we need to get our data, we need to get our result properly without any glitch. So that's how we accomplished.
In your application, Bhaskar, you if in case you enable multi-ag means all the
Hmm.
8 nodes will be replicated to another region. You have 16 nodes complete 16 nodes. In case in
Yeah,
your
yeah,
application.
that's actually available, but nodes are not physically available in different zones. But this cluster is available to access from different regions.
Mhm.
That's how. So even though you switch it to different region, so you can access the cluster.
Okay. In that slide, there is endpoint and JDBC, ODBC URLs are there. What is the
Correct.
use of that URLs? We actually in RDS we use only endpoints to connect application or from user interfaces. What is the use of this
Yes,
JDBC, ODBC URLs?
yeah, this URL, say for example, you have glue job. So we wrote a glue job actually. They're actually using psycop G2. I tried
Mm,
to build the connection over there. So while building the connection, I need to have this information. That means in order to connect with the Redshift cluster, I
mm,
need to take the help of JDBC. For that JDBC, what is the URL? I mean to say
mm,
in the AWS, when you create a connection, so we
mm,
have connections, right, in the glue. So when you try to
mm,
create a connection over there, there actually we can have different databases in that Redshift is there. So when you choose Redshift, it will ask for the JDBC URL. You can directly come to the cluster, you can copy this JDBC URL, paste over there
mhm.
so that
Okay,
the glue is able to connect to the Redshift.
okay,
Okay.
okay.
So this is how
That's it.
in our course we'll be covering so different aspects of Redshift. That
In
means
basically
how.
for glue purpose, we use JDBC URLs,
And
ODBC.
not only glue. If any client application, as I mentioned in the see here in the cluster, in order to connect to the cluster, Redshift cluster, so
Okay.
we need JDBC or ODBC or Redshift Data API. So using these only we can connect to the Redshift. Otherwise, we cannot.
Is there
The,
any
this
specific applications for that use JDBC or ODBC apart from API? Sorry, endpoint. Is there any specific reason? Generally, our
come again.
applications use
Come again.
endpoints. Basically, in our RDS environment, we share application team our endpoints. We don't have
Mm,
JDBC and ODBC
mm,
uh, URLs. Is there
mhm.
any specific use case by using JDBC and ODBC URLs
Yeah,
apart
definitely. Even
from
Lambda also.
endpoint?
Yeah, in the Lambda we have used, in the Glue we have used, in the Lambda we have used Redshift Data API also.
Mhm. Okay.
Yeah, basically the connection to provide the connection to build the connection with the Redshift cluster, we need
Mhm.
this.
Okay.
Okay,
It
all
is a
good.
choice. It is only choice. Selecting JDBC, ODBC, or endpoint is a choice. We can use anything. Is there any specific reason to use JDBC or ODBC like that? I would like to know.
No, okay. I ask you one question.
Uh,
How do you connect with any? database? Say, for example, Todd is there
Uh,
or dbeaver is there. How do you connect with
we use
Oracle?
endpoints. Basically, we take endpoints and we will connect with endpoints.
Right. So endpoints. So within the endpoints, basically, what is there? Without
Uh,
this JDBC information, you will have this. All this is same. If you see any client application, SQL Developer or dbeaver or Toad, whatever it is, you
mhm,
just give host, username, password, database details.
mhm,
But there is actually when you try to test the connection internally, that application will install the driver software. That driver software is the JDBC, or
mhm,
maybe you can use ODBC also. Without
mhm.
JDBC, ODBC, you cannot connect to the cluster. Maybe, yeah, Redshift data API is there. Yes, using this data API also, we can run our queries from the client application.
Okay.
Yeah.
Is this
Okay.
data is stored in slices?
Yeah. This compute node, again, this split into different slices. How
Okay.
the data is. Mhm.
Yeah, for each compute node, how many slices will be there?
It depends. It's kind of
Okay.
interview, buddy. Are you learning here or how?
No, 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 I'm learning.
You're learning, right? It is so learning means it should be in such a way that so
Yeah,
okay.
okay.
Anyhow, workload management will be
Final
yeah.
conclusion is, Bhaskar, we will
Mm,
get yeah, high availability without
mm,
configuring high availability in Redshift. With the compute nodes, multiple compute nodes, we will get high availability. Basically, we no need to
mhm.
configure multi-AG,
Cluster,
right?
cluster meant for high availability.
Uh, Means
Mm,
one of the node will get down also. We don't have any issue without configuring
mm.
multi-AG in Redshift, in
Yeah,
particularly Redshift, right?
yeah, yeah,
Okay. Because I don't have any idea on Redshift, that's why.
yeah, yeah. Multi-AZ is the cluster is available in multiple available zones.
Mm,
Multi-AZ no is this cluster is not accessed by different zones. It is confined to a particular region.
mm,
That's how it is. Okay.
mm.
If you switch to different region, you don't find the cluster. You may ask, hey, what happened? What's happening? I can't see the cluster here. Then somebody comes and say, hey, first switch to this region, buddy, so that you'll see the cluster.
Okay.
Okay, the all the resources cannot be accessed by all the regions. Wherever the services or resources, AWS services, which are multi-AZ, then you can access those resources from different regions. If that service is not multi-AZ, then you cannot. You can access that particular service from single available zone only, single region only. Okay.
Means okay, okay,
Hmm.
Bhaskar. But actually, multi-age means availability zones are in the same region only, na?
Yeah, the region, so different uh, multiple available zones.
Ah,
Don't get confused.
okay,
What are available zones? What are regions? I'll come to that part.
okay,
Okay.
okay. Mm,
Yeah. Why multiple available zones? Why different regions? How to enable, how to ensure the highly availability? We will come to all that part in the coming classes.
okay.
Right?
Mm,
Thank you. So, as part of this course, we'll be covering. So, by this time, I'm sure you have basic knowledge of SQL so that we can go further. I think I don't have to teach the basic commands of the SQL, like what is select, what is from class, what is where class. So, these kind of things I don't have to teach, right?
mm, mm.
Yeah.
Yeah. Thank you.
Thank
So
you, Bhaskar.
thank
You
you
are
so
from
much.
Hyderabad, Bhaskar?
Yeah, yeah, from Hyderabad only.
Okay, okay.
Yeah. Thanks, buddy. Have a good day.
Thank you, Bhaskar. Yeah, have a good day, Bhaskar.
Thank you. Thank
And
Yeah.
you.
what are the timings, Bhaskar, for this class?
So yeah, mostly morning hours only because from afternoon onwards, like around 11 o'clock, I'll be busy till night 8 o'clock, 9 o'clock. Then after 8, 8:30, I'll be free. So either morning or after 8:30 p.m. we'll have classes. Mostly this class, I'm planning to have these classes in the morning hours only.
Okay.
Right, and we'll be, so we'll be covering, it's purely hands-on. It's not like, so covering the topics in the PowerPoint slides. It's not like that. So it'll be hands-on completely. So you will have to enable your free tier account. Okay, so to log into the console, AWS console, and how to, enable the cluster. Maybe for free tier account, it'll be on only one node. So you'll get in the cluster. So in that way, let us, get hands-on. We'll get our hands dirty that way, so that you'll feel confident end of the course saying that, okay, I have done this in the Redshift in any corner. I'll have good knowledge. I have good knowledge on it, so I can crack the interview. So you'll have that confidence at the end of the course. I'm sure for that. Okay. So with this, I'm ending the session. Okay.
Oh, okay. Thank you.
All
Yeah,
good.
thank you. Yeah, all good.
Thank
Thank
you.
you.
Thanks all. Yeah. Bye
Thanks.
bye.
Bye bye.